Hello students. So today we will be discussing about the physical state of chemical species while writing in equation. Okay. So when you write a balanced chemical equation, we have to mention the physical state of each of the chemical species or compounds that is present in the chemical equation. Okay. So while writing the physical state, we have to always remember that there can be four types of physical state of a chemical species. Okay, so what are they? One is the solid, then liquid, gas, and aqueous. Okay, so these we all know that there are generally three physical state of any matter, that is solid, liquid, and gas. Okay, so now what is aqueous? So aqueous state is written or it is mentioned when any of the chemical species is dissolved in water. Okay, if any chemical, any compound, any salt, when it is dissolved in water before using in a reaction, then we mention it as aqueous state. Okay, so now this writing a physical state in chemical reaction, it is confusing. Okay, so most of the students, they faces difficulty to mention the physical state while writing the chemical equation. Okay, so generally we can easily categorize some of the different types of compounds or different types of elements based on their physical state. So I will be trying to help you out to reduce your confusion, okay, in this part. So let us look at this topic one by one. Okay, so we'll be looking at each of the state one by one. So let us consider first solid state. So you can consider this as a unsaid rule. Okay, that all metals may it be sodium, potassium, calcium, magnesium, all metals are solid. Okay, are always present in a solid state whenever they take part in reaction, but the exception is mercury. Okay, so why mercury? Because we all know that mercury is a metal which exists in its liquid form. Okay, so this is an exception. Okay, so this is the chemical representation of mercury, right? So next, salts. So all the salts, okay, generally we all know that salts are generally solid. Okay, and out of these salts, generally those salts that are insoluble in water, like barium sulfate, calcium carbonate. Okay, so these salt, barium sulfate, calcium carbonate, they generally exist as solid. Okay, so all these salts generally exist as solid. Again, the third one, okay, that is metal oxides. Metal oxides like iron oxide, magnesium oxide, all these exist in its one of the famous oxides, calcium oxide. All these exist in its solid form. Okay, so they exist, all metal oxides, they exist in their solid form. Okay, so if you find this type of species, this type of compound in your chemical equation, that is either there is a metal or there is a salt or metal oxide, and the salts which are generally insoluble in water. Okay, so we will discuss again the salts are also present in solid state, you can see, and salts are also present in aqueous state. So this is the main reason of confusion while writing the physical state. So we will be discussing the salt in more details after some moment. Okay, but generally you can write that solids, that is all metals, they exist as solid form, salts, they exist as solid, and metal oxide, they also exist as solid. Okay, now liquid. So it is quite simple that generally all liquids, that is water, ammonia, ethanol, and bromine. So bromine is the only non-metal that exists as liquid. Okay, so all chemical compound, like all these chemical compounds like all these species, they can exist as liquid. Okay, generally exist as liquid. And gases we all know: oxygen, hydrogen, nitrogen, carbon dioxide, sulfur dioxide, Okay, all these exist as gas. Okay, so now one of the important part, that is aqueous state. So what is aqueous state? I have already said that when any of the chemical species is first dissolved in water, okay, if that chemical species is first dissolved in water, then it is used in reaction, then we mention the physical state of such chemical compound as aqueous. Okay, now I have written here acids. Okay, I have written here acids. So all acids, so nature of the acid is totally fully concentrated. Okay, or the acids that are generally used in lab are not totally 100% acid. Okay, so they have some amount of water in them. Okay, and most of the time they are generally diluted. So what dilution means? That is, acid is added to water. So acids, all kind of acids, they exist in aqueous state. Again, the bases, generally we say that most of the bases are insoluble in water, but the bases like sodium hydroxide or potassium hydroxide, they can be soluble in water. Okay, so since they are soluble in water, so we can mention their physical status aqueous. Okay, and in some salt like sodium chloride, that is the common salt we use in kitchen. Okay, and copper sulfate. Okay, these salts are easily soluble in water. Solution of copper sulfate will give you blue color solution. Okay, so these salts which are easily soluble in water also are in their aqueous state. Okay, so you can easily classify them. Now we'll be looking at salts. Okay, since we have mentioned salts are, so some salts can be solid. Again, we are saying that some salts can be in aqueous state. So it is really confusing. Okay, so what happens? That salts that are generally insoluble in water exist as solid state. Okay, and the salts which are generally soluble in water generally exist as in their aqueous state. Okay, because in their aqueous state, since they are soluble in water, they can easily participate in the reaction. Okay, so this will be more clear if we take some examples of some reaction. Okay, so we can understand better when we will take the example of some reactions. Okay, so we'll now look at some example of reaction and what are their physical state of each of the chemical species or each of the compound taking part in this chemical reactions. Okay, so now let us look at some examples of reaction. Okay, so this is a type of reaction, that is decomposition reaction. So when you will read the other topics of this chapter, okay, the succeeding topic of this chapter, you will come to know about different types of chemical reaction. So decomposition is a type of chemical reaction. Okay, so this is an example, that is ferrous sulfate is heated. Okay, so when ferrous sulfate is heated, it decomposes to iron oxide, sulfur dioxide, sulfur trioxide. Okay, again calcium carbonate, when it is heated, it gives calcium oxide and CO2. So from this, in our previous discussion, that is earlier, I have already said that metallic oxide. Okay, these are metallic oxides. So they always exist in this their solid form. Okay, and solid form is represented by S, and these are gases. Okay, so this will be represented by G. Now what you can see, that in decomposition reaction, the salt that are taking part in decomposition reaction, so they are generally in their solid state. Okay, so if they will be in their aqueous state, so they will not decompose when we heat them. Okay, so generally the salts that are present in the decomposition reactions, they are always solid. Okay, in their solid state. Now let us come to the displacement reaction. Okay, there will be displacement or double displacement. So this is an example of displacement reaction. This is an example of double displacement reaction. Double displacement reaction. Okay, so what you can see, that the salt that are in the reactant side, okay, the salt that are present on the reactant side are generally in their aqueous state, because they are taking part in the reaction. So if they will be in their solid state, it is difficult for them, or the reaction will take much longer time. Okay, so generally in displacement or double displacement reaction, the salts that are present in the reactant side are in their aqueous state. Okay, this is also in their aqueous state, this is also in aqueous state. And generally in displacement reaction, mostly we can see if no precipitate is forming, okay, if no precipitate is forming, then the salts in the product side is also in aqueous state. Okay, so here we can see that ferrous sulfate is in aqueous state. Here we are saying that ferrous sulfate is in solid state because this is a decomposition reaction and this is a displacement reaction. What we say that in displacement reaction, generally the salts are present in their aqueous state, but in decomposition reaction, the salts are generally present in their solid state. Okay, but in case of barium sulfate, okay, so when these reactions take place, barium sulfate, it forms as a precipitate. Okay, it forms as a precipitate. So what is precipitate? We will come to know in the later part of this chapter. Okay, so this barium sulfate forms as a precipitate. Okay, so once all precipitate exists in their solid state. Okay, so barium sulfate will be also present in its solid state, and this is ferrous chloride. Okay, so this will be present in its aqueous state. Clear? So by the type of reaction we can predict what will be the physical state of the salt. Okay, so the confusion related to the salt can be solved, okay, or can be reduced if we know what type of reaction it is a part of, or the salt is involved in which type of reaction. So in decomposition, generally the salts are present in solid state. In displacement or double displacement reaction, if no precipitate is forming, then all salts are generally present in aqueous state, and if precipitate forms, then the salt whose precipitate is forming, that salt will be present in its solid state. Okay. So this is the basic of writing the physical state of the compound of the salts of any chemical species that are taking part in a chemical equation. Okay, so I hope this will be helpful for you in determining the physical state while balancing a chemical equation. Okay, so you can try for different example in your home, and if you face any difficulty you can contact me. Okay, thank you.